All right, so what we're doing today is graphing systems of inequalities. We're graphing systems of inequalities. So what that means is that we're going to be graphing multiple inequality equations. Now, we worked on actually graphing one at a time. So we talked about this last week. We never had to graph one of these in two variables. And whenever we graph these, so we can look at the first one here. Y is less than or equal to 3. Y is less than or equal to 3. Well, whenever we have a variable by itself, so y, whenever y is by itself, we're either talking about a horizontal line, so it's a horizontal line when we have y by itself, and it is a vertical line straight up and down when x is by itself. So here we have y is less than or equal to 3. So we find the point where y is 3, and draw our line straight across. And because it is equal to, the line is solid. The line is solid when it is equal to, and it is dashed whenever it's just less than or greater than. Any questions on any of this here so far? We good with this here so far? Yes? Now we need to check a point to see where this is true. Well, we can always check the point 0, 0. And if I plug this in to check it, we get 0 is less than or equal to 3. Is this true? Because 0 is less than 3, yes? So before we go and shade, because again, we have a system this time. How many equations do we have? 2. So what we do, and what I do, is we can shade, but I draw the direction. Because 0, 0 is below the line, I'm going to draw 2 arrows going down. And for what we're doing here, this isn't bad having 2. But when we have more than one equation, looking at this here, and when we just shade, it's going to make it hard to see what is actually the solution. So I'm going to do this here to make it a little bit easier, a little bit nicer looking. Since we know 0, 0 is true, it's below the line, we're going to shade below it. Okay. So we've done everything we need to do for y is less than or equal to 3. For graphing it, we know which side we're going to shade. Okay. Now we're going to look at y is greater than x plus 2. Okay, since it's greater than our line, is it going to be solid or dashed? Dashed because it is not equal to it. Okay. Now, where do we start for this here? If I'm going to graph y is greater than x plus 2, where do we start? We start at the 2. Because the 2 is the what? The y-intercept. And where can we go from here? So we can go up 1, right 1, or we can go down 1 and where? Left 1. Because if we go up 1 and right 1, we have a positive slope. If we go down 1 and left 1, we still have a positive number. Because a negative and a negative make a. It's here and there. Because here, since we're talking about inequalities, it's not just the point that they intersect, because the point of intersection may or may not be included, but we're looking at where they are the same, where they have the same shading. Now again, we need to check a point, because just like we do with any of the inequalities in two variables, we have to check a point to see where are we shading. So we can check 0, 0. So if I plug this in, we get 0 is greater than what? So 0 plus 2, which is just saying 0 is greater than 2. Is this true? Well, no. So when I look at this line, this dashed line, and again, we check this point. Let me color it a different color. So we check the point 0, 0 here, yes? And since it gave us a false statement for the dashed line, we're going to shade away from it because it's not including that side for the dashed line, yes? So we're going to shade above it. So what? So right now we have the system of inequalities, yes? Because we're trying to find, for systems of equations, we're trying to find the values of x and y that would make both statements true, yes? For systems, we looked for where they intersected. So where do these intersect? Where are they the same? Where are the arrows pointing in the same direction? Because we only shade where the arrows are pointing in the same direction. Because if we look at this here, I'm going to get a highlighter out. So here in green, is anything in this section true for y is less than or equal to 3? Well, no, all those values up there are false for y is equal to 3, yes? And for a system, we need both statements to be true. So that means everything where I highlighted in green is false for y is less than or equal to 3, yes? So none of those values would work. Right, so anything up here in the green highlighted won't work. Now everything here in blue would not work for our other equation, correct? Our y is greater than x plus 2, yes? Yes. So even though some of this works, not all of this works for y is less than or greater than x plus 2, correct? Well, that's why we drew the arrows, because anything going this direction here is true for this equation, yes? And anything going down from this equation line is true for this one. So anywhere both arrows are pointing in the same direction or pointing towards each other will be true for both. And that's the spot we shade. So for these two equations, just this little section here, any numbers in that section will be true for both of these. Will be true for both of these equations. Questions on this here? We good with this here? Yes? Okay. Any other questions on this here before we move to the next one? Okay. Let's look at this one here. I'm going to start off with that one. Mainly because that one's a little bit easier to draw, because if we have x equals or y equals by itself, it's either a horizontal line or a vertical line. Horizontal or vertical. It's going straight up or straight down. Because it's y, which direction are we going? Horizontal. Y by itself is horizontal, flat line. And it's at what? Y equals? And because it's equal, will the line be solid or dashed? Solid. So at -1, we're going to have a solid line. It would be better if I could actually draw a nice straight line. Yep. We have a solid line. There we go. Now for this here, we can check a point. What point do we want to check? 0, 0. And this would tell me what? 0 is greater than or equal to -1. This is true, yes? So we would be shading where? Above the line, yes? So for this here, we're going up. And again, you can draw multiple arrows. You can draw one arrow. But we are going up. We're shading above this line. All right. Let's look at the other equation. Y is less than negative x plus 2. Is the line going to be solid or dashed? It's going to be dashed because it is not equaled. Now, where do we start? At positive 2, because we have x plus 2. This is our y-intercept. And where do we go from here? Because exactly, because our slope is negative 1. So we go down 1, right 1. Or I can go left 1. Okay.
Why would you go down 1 to the right?
Because it is negative.
So what makes it go to the left? I know what makes it go to the left though.
Because left is what? Positive or negative?
Positive.
Negatives are always to the left or down.
So if this is negative, why are you going to the right?
Because where did I go? I went down, which is a negative direction, yes? If I wanted to stay negative, I need to go in a... Now, if I go up, up is positive, and if I want a negative slope, I have to go to the... Questions? Because for negative slopes, we can either go down and right or up and left. Because down would be negative and right is positive, and negative and positive is a negative. If we go up and right, well, up is positive, right, not up and right, up and left. If I go up and left, left is negative, while positive and negative is still a negative. Because if we go up and right, positive and positive is a positive. If we go left and down, a negative and a negative is a positive. Then if we graph this line, we get something like this here. And it is dashed because it is not equal to. And is this going down? Do we have a negative slope? Because as we go from left to right, it is decreasing, it is going down, yes? Okay. Now we need to check a point. 0, 0. It's not going through the origin or the point 0, 0, so we can use it. Tells me 0 is less than, well, negative 0 plus 2. 0 is less than 2. Is this true? Yes. So the origin is here. So we shade towards it, shade towards that point. So we get this here. So we want to shade where the arrows are in the same direction.
So that whole entire area again? No, I don't see right here.
So it'd just be this little section here. Questions on this here? We're getting this here, yes? Okay. Now, you might be wondering a little bit, why do I say we do the arrows and not just shading? So say we got this here. And I said, okay, we're going to shade above this line. I shade all of this in here. Well, we know that we're shading all of this in here. Well, in our answer, wait, y'all don't like that? No? That's a lot of shading, isn't it? Okay. Well, it's a little bit nicer, and this helps with this whiteboard. I'm going to get over here so I can use a highlighter. And this doesn't quite work with the real highlighters. Let me save this here. Let's go back. I don't know. Start with light blue. Okay. And then the spot in green is our shaded area. So it worked a little bit with that. But if you notice, when we start trying to shade everything as we're going, it gets very, very messy very quick, yes? Can you imagine doing this with 4 of these equations? No, that'd be really, really messy, yes? Okay. So that's why I like using the arrows, because it's not as messy. There's not as much going on. Okay, we're going to look at another one, this one here. Well, this time they didn't give us a y equals just a number. They gave us 2 equations, yes? Okay. We can start with this one. Y is greater than 2x minus 3. So is the line going to be solid or dashed? Because? Yes. Because solid. It will be dashed because it is not equals. So it will be a dashed line. Now where do we start? -3 because it's the y-intercept. So I'll go down -3 on the y-axis. And where do we go from here? Because our slope, our value for m is 2 over 1. Even though it's just a whole number 2, it's really, we can write it as 2 over 1. Because anything divided by 1 is just the number itself. 2 divided by 1 is still 2. And because it's positive, we're going to go up 2 and over 1. And we can do this again, up 2 over 1. And we could keep repeating this over and over again if we wanted to. And what we're going to draw is a dashed line. Any questions on this here? Now we just need to find out which side we want to shade, yes? So to determine which side we want to shade, we need to check a point. So 0, 0. And if we plug this in, we get 0 is greater than 2 times 0 minus 3. Because 2 times 0 is, and 0 minus 3 is just -3, yes? So we're going to shade, when we shade, for this line here, we're going to shade towards the origin, because 0 is greater than -3. All right. Let's look at the other equation. Y is greater than or equal to 1/2 x plus 1. So we have this here, yes, because 1 is our y-intercept. Now our slope this time is 1/2. So this time we're going to go up 1 and over 2. So we go up 1 and then over 2 to the right because it is positive, yes? So for positive, we can have up and right. Up is positive, right is positive. Positive and positive gives a positive. Now, I could also go left and down. Because left is negative and down is a negative direction. And a negative make a positive. So we can go in either one of these two. So we could also go down 1, right 2, up 1. Now this line here will be solid. I missed it. There we go. And lastly, what do we need to do? So check 0 as 0. So 0 is greater than or equal to 1/2 times 0 plus 1. So we're going to shade away from the origin where these two axes cross. So where are the arrows pointing in the same direction? Yep. So since they're both going up, we want the direction where they're both going up. Now this spot over here and this spot over here are only true. So down here it's only true from the green dotted. Up here is only true for the solid black, where I circled those two spots. So they're only true for one. The only real spot that's true for both is this up here. This is the only place where both equations are true, is in that upper top corner. Because we still have a few more that we're covering here. Any questions on these here? Okay. Okay, this is probably going to be the last one. This is going to be the last one we do today. So these here are the same. Then y is not by itself. We could get the y to be by itself, or because how many points do we need to graph a line? 2, yes? So we can use the intercepts. 0, comma, plug in 0 for y and 0 for x. Now, I would make sure on the side next to that you have a little bit of extra room so that you can write these two in. I'm going to have to erase because I don't quite have the same amount of space y'all do on your paper. So we'll start out with plugging 0 in for y. So if I plug that in, we'll have 2x plus 0 is equal to -1. Now, we switched it to equals because we're trying to find the point that is on the line. It's going to make it true. It's this true statement. So we're not really looking at shading greater than or less than. We're trying to see what points are going to make this line. Well, 2x plus 0 is 2x. And to get x by itself, we can do what? Divide both sides by 2. Which tells us x is equal to -1/2. So our first point is -1/2, comma, 0. And that's what we need to do. Questions on this here? So we found one of the points, yes? So now we need to find the other. So this time we're going to plug 0 in for x instead of for y. So we'd have 2 times 0 plus y is equal to -1. Well, 2 times 0 is, it tells us y is equal to, and that's it. Questions on this here? So what are our points? So 0, -1, and -1/2, 0. So, so we'd have these 2 points. So we don't go up or down. We're just plotting the 2 points. So -1/2, 0. So I go -1/2 on the x and 0 on the y. So we're just right there on the x. And 0, negative 1 is just down 1. So we have these 2 points here, and they're actually really close to each other, yes? That's fine. There's nothing wrong with that. Now, is the equation equal to, or, so it would be dash, because it's not equal to, yes? Yes, less than. Try this again. So we can draw a dashed line straight through those points. We can draw a dashed line straight through those points. So we still need to check a point. Because it's not going through the origin, it's not going through where these two intersect at 0, 0, we can use it. So we'd have 2 times 0 plus 0.
So we would say
Because here 0 is not less than negative 1. 0 is bigger than negative 1, so it is false. So we would shade away from it. So any other questions or any questions on how we did this first equation or this first line? Okay. Well, now we need to, so we are finished with the first equation. Done with this. 2x plus y is greater than 3. So I need to do the same thing for this other equation. So we look at this here, we can start off, because we're going to do the same thing we did with the first one. We can plug 0 in for x and solve for the value of y. Well, 2 times 0 is 0. So y would equal 3. When the value of x is 0, the value of y is 3. Now we can do the same thing for the other one. We can do 2x plus 0 is equal to 3. This time we plug 0 in for the value of y. Well, 2x plus 0 is just going to be 2x is equal to 3. And what do we need to do to get the value of x by itself? Y. Almost. 2. Which tells us x is equal to 3 halves. So do we have our 2 points now? Yes. So 0, 3, 0 on the x and 3 on the y, so that means we're going up 3. Now 3 halves, where would 3 halves be? What would it be between what two numbers? 1 and 2. Because 3 halves is the same as what? 3 halves is the same as 1 and 1 half. It's the same as 1.5. So we have these two here. So we have our 2 points, so we can draw our line. Now, will our line be solid or dashed? Dashed. Almost done. Now we just need to figure out which direction we are shading. So we can check 0, 0. So 2 times 0 plus 0 is greater than 3. Well, 2 times 0 is? So we shade away from the origin, yes? Away from this point in the middle. So where are the arrows pointing in the same direction? They're not, are they? So this here would be what? No solution. So if it's not pointed in the same direction at all in any place, this would be no solution. So this is where we're going to stop for today.